All right, example 4. Again, graph, describe the transformation, and give the domain and range. Step 1, identify that vertex. So looking here, now we have nothing grouped with the x that is being added or subtracted. Notice we do have multiplication, that is a scale change. So since there's no addition or subtraction in the asylum, our x-coordinate is 0. Outside the asylum, positive 5, it is normal, so it's going up 5. Scale change, so here I'm going to describe the whole transformation. The scale change, we are multiplying by the x inside the asylum, so it is horizontal. I'm going to skip the stretch or compression for a second and give the scale factor. Remember, in the asylum, it's the opposite operation. It looks like we're multiplying by 3, we're really multiplying by a third. Since our scale factor is between 0 and 1, we have a horizontal compression. The shift we talked about is up 5. And we're multiplying by a negative, so it opens down. And we answered step 3. So now we will use the parent function to scale change. But when we plot, we will first plot our vertex. So parent function t-chart real quick. And because it is horizontal, we will be multiplying our x-coordinates by 1/3. Typically, we would leave our y-coordinates alone, but because it opens down, our y values become negative. Alright, so when we graph, we start with the vertex. So plot your vertex first, 0, 5. And then use the new t-chart for directions. So from your vertex, we are going to go left 2/3, down 4. Left 1/3, down 1. Right 1/3, down 1. And left 2/3, down 4. Now this one, because it's so skinny, it's going to be hard to get it to be rounded at the vertex, but do your best to make sure that I see some sort of curve through that vertex and not a sharp point. All right, last piece, domain and range. We're going to get a room here, so I'm going to change colors so we can see it a little bit more clearly. Domain, always all real numbers. Range, start with y. It's opening down, so when we look at the graph, we can tell all of our y values are less than or equal to the y-coordinate of our vertex. One more graphing, just for some extra practice, to see it one more time to try and put it all together. We're going to describe the transformation and give the domain and range as well. So first step, vertex. Inside the asylum, I see no addition or subtraction, so the x-coordinate of my vertex is 0. Outside the asylum is normal, I'm going down 8. So here's step 2, I'm going to describe the whole transformation. So my scale change is inside the asylum, grouped with the x, so it is horizontal. Skipping the stretch or compression, I'm going to talk about the scale factor. When I pull it out of the asylum, it becomes the reciprocal. It looks like I'm multiplying by 1/4. I'm really multiplying by 4. Because it's greater than 1, this is a stretch. Looking at the shift, we're going down 8. And I see no multiplication by a negative, so we're opening up, which was our third step. So now we're going to take a look at that parent function. And we are going to multiply our x values because it's a horizontal stretch. And we're opening up, so our y values are going to remain exactly the same. So multiplying all of my x-coordinates by 4. And leaving my y values alone. Finally, we're going to put it all together with our graph. Start by plotting your vertex. So I'm going to go down 8. And then remember the T-chart gives me directions. So from my vertex, left 8, up 4. From my vertex, left 4, up 1. From my vertex, right 4, up 1. And right 8, up 4. All right, so this one looks a little challenging to get it rounded as well. It almost looks like a V, but it is not. It's been stretched quite a bit, but it's still a parabola, so try really hard to get that curve going and no straight lines with our parabolas. All right, finally, domain and range. Domain, all real numbers. Range, we're opening up, so y is greater than or equal to the y coordinate of our vertex. One more example, just so we don't have 4 videos. Writing the equation. So now taking the information and putting it into equation. The steps are the same as for graphing. First, figure out what the vertex is. The vertex is any translation, horizontal or vertical. So I am shifting it 2 units right, 4 units up. So I'm going to start my equation with x to the right would be positive, but it's going in the asylum. And 4 units up is outside the asylum, so it's normal. I left a little room for the scale change because I haven't looked at that yet. So I've got my vertex and I put it into my equation. Scale change. Vertical compression. Vertical goes outside the asylum, and notice how I changed my wording. So now I'm giving you the scale factor. So I'm still being precise with my language, but instead of trying to have you figure out the scale factor, I'm giving it to you to make it a little bit easier. Scale factor is 1/5, goes outside the asylum. Does it open up or down? Opens down, which means I'm multiplying by a negative. And the U tries.